Let's recap and summarize what we have learned so far about OSPF. OSPF is widely used. It is a dynamic link state routing protocol designed for use within an autonomous system. It's part of the Internet Protocol suite, and it operates at layer 3, which is also known as the network layer of the OSI model. Key features. We covered the key features, but let me just go through it again quickly. One of the key features is, of course, it's a link state protocol. And what does that mean actually? OSPF maintains a map of the network topology using a link state advertisements. Each router in the OSPF domain builds a complete topology of the network to calculate the shortest path to destination. It is an open standard. We don't need to say much about it. It uses a hierarchical design. OSPF supports a hierarchical structure using areas, which reduces routing overhead and improves scalability. Area 0 is the backbone, and it's the central to all OSPF designs and connects other areas. It uses a cost to calculate its bandwidth to determine the best path. It has fastest convergence. OSPF quickly detects changes in the topology and recalculates the routes, ensuring minimal downtime. When it comes to security, it has its own authentications and design. It supports plain text and MD5 authentication to secure routing updates. It is a classless routing protocol. It supports variable length subnet masking and CIDR, which is a classless internet domain routing. Multicast addressing, this is how it discovers its neighbors, uses a multicast addresses of 224.0.0.5, and that is used by all the routers in the autonomous system. 224.0.0.6 is used by the designated routers for communication. I hope this is clear. Now the components of the OSPF, we have already gone through this in our lectures and when we were doing the labs, but let me again go back to it just to refresh this information again. It's nice to use router IDs when it comes to designing OSPF. It's a unique 32-bit identifier for each router. If router ID is not used, then it uses the highest IP of the active interface or the one that's manually configured. OSPF uses areas, backbone area, which is also known as area 0. It is central to all other areas. All non-backbone areas must connect to area 0. Non-backbone areas can include regular areas, stub areas, totally stubby areas, and not so stubby areas. We have covered that in depth in our previous lectures. And then it uses link state advertisements, and there are types of the link state advertisement. OSPF routers exchange LSAs to share topology information. The types of the LSAs include type 1, which is the router LSA, type 2, which is a network LSA, and type 3 is the summary LSA. Now type 1 LSA is only responsible, that router is only responsible for those LSAs that are within the area. Type 2 is a network LSA, which is produced by the designated routers, and type 3 is a summary LSA between the areas. Type 4 is an ASBR summary LSA, and that's for external routing information. Type 5, which is also known as the external LSA, is the external routes from the outside of the AS domain routing protocol. Type 7 is the NSSA LSA used in NSSA areas. We covered that in detail in our previous lecture, and you can review that. Now let's continue with the components of the OSPF. The other main component is the neighbor relationship. OSPF routers form adjacency with directly connected neighbors by exchanging hello packets. Designated routers and the backup designated routers reduce OSPF overhead on broadcast and non-broadcast multi-access network. DR and BDR handle the LSA distribution for the network. Now OSPF operations, we have already talked about it, but here is again just to refresh your mind on it. The neighbor discovery, how does it happen? Routers send hello packets to discover neighbors and establish adjacencies. Parameters like hello and dead timers must match for the adjacency to form. Database synchronization, routers exchange their LSTB, which is the link state database, to ensure consistency. SFP calculations happen as well. Each router runs the Digestra algorithm to compute the shortest path tree based on the LSDB, and routers are populated in the routing. The routes are always populated in the routing table. So the best paths are always going to be in the routing table, and those routes will be used. Route distribution. OSPF can redistribute routes from other protocols or static routes within the ASPR. We have covered that in our lab. Now the advantages of OSPF, we have talked a lot about it. Scalability is one thing. As you know, OSPF uses a hierarchical design and it supports large networks. It has fast convergence, quick response to topology changes, load balancing. It uses ECMP for routing, which supports equal cost multipath. It's a vendor neutral, works across multi-vendor environments. It's efficient resource usage. LSAs are only sent when the topology changes occur. The disadvantages are, however, concerning because of the complexity. Configuration and management can be challenging in large networks. Resource intensive, consumes more CPU and memory compared to simpler protocols like REP. So it does consume higher CPU and higher memory, but again, to the benefit of, it manages larger networks, so you need to have much more powerful routers. Area design requirements. Poor area design can lead to inefficiencies, unfortunately. With this, I will conclude the course of OSPF. I will try to improve much more down the road. But I know a person who knows OSPF very well, and he manages day-to-day OSPF protocol, and that's his job. He's actually called in a lot of time to improve the routing structure of an organization and redesign the OSPF. I encourage, if you want to be an expert on OSPF, do not shy away from it, because OSPF can be a protocol that could lead you to a better career in network engineering, and very few people understand OSPF very well. Yes, in smaller networks it may work automatically, and you don't have to do much, but in larger networks where you will be redistributing routes from different routing protocols to OSPF, as well as designing 3-layer hierarchical structures, then of course OSPF and knowing OSPF will give you that advantage. And I hope in this course I have delivered that, and see you again in my next courses. Thank you again.